3 sample problems for 4-3 day 2. Less explaining, just doing. So here we go. Multiplying fractions. All right, can I start picking stuff off? No. Factor, 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 factor. X squared minus 16 is x minus 4, x plus 4. 9 minus x, like I've been saying, got this floating little binomial, slap some parentheses around it, times, now this is a trinomial. They're getting a little nastier with their trinomials, but what are 2 factors of negative 90 to add up to 1? Well, 10 and 9 are jumping out at me. The positive one needs to be the bigger one, and there we have it. Boil that out if you question yourself. Then, same thing, a little bit bigger numbers. 2 factors of 40 that add up to 14. I'm thinking 10 and 4, and they can both be positive. Now I go on a hack fest. Clearly, these are the same. These are the same. Watch this now. Exact opposites. Boom, boom, negative 1. What's my answer? Negative 1 times x minus 4. Now the book might distribute this, or an ACT question, so be prepared to distribute it, but both of these are good. Now it does ask, I forgot, find the domain. Well, x can't equal 9, x can't equal negative 10, x can't equal negative 4. I'm not going to write it down, okay? Remember, find the domain after you factor, right before you hacker. I just forgot. All right, now some of you are like, well, I can find the domain right now. X can't be negative 5. Be careful, that's not really in the denominator. So, I'm going to rewrite this. I'm going to go ahead and factor this too, just to save a little time. X minus 6. I'm slapping parentheses around that. Times, flip this, x plus 5, x minus 6. So the domain, you have to be patient until you get to this point. X can't be negative 5, x can't be 6. Now I go on the hack fest. Look at this, baby. Boom. Okay? Boom, boom, boom. One more example problem. Last problem for 3 day 2. You can take a look. It's like, uh-oh, I didn't think I signed up for geometry class. One thing I really love about this book and the authors of it is they really try to take real life applications and apply it to the math we're learning. And a lot of students get frustrated, like, when am I ever going to need this? Well, believe it or not, Michigan State, those Sparties, they've got one of the leading programs in the world, at least this country as far as I know, packaging engineering. Now, you may not think that that's exciting, but one of my buddies that I graduated with actually became a multimillionaire by age 43, 44, 42, by going into this. And he killed it. He made cardboard. So he loved it, yet he was good with machines because it's a factory. But he owned it and ran it well, and he had a lot of knowledge of this sort of thing. So with that in mind, math. They give you a cube, and there's a cylinder. Now, they pretty much spoon feed us the formulas, so I don't want to intimidate you with that. But they're going to ask, okay, you have a company, it's about making these packages. Is it more efficient to make them out of a cube or out of a cylinder? Now, there's a formula, surface area divided by volume will give you the efficiency of that particular design of the product. You go to the grocery store, they're not all the same design, so there's people trying to figure it out, but there's also a psychological part of that too they have to study. Anyways, get too excited about this. Here's the surface area of the cube, and here's the volume. How do we find the efficiency? Well, I'll do this one in red. I've got to take this crazy looking formula that represents the surface area of this. Surface area is just, you take one side, find the surface area, and multiply it by 6. They've made it look pretty fancy. But we're just going to go with it. So 2 times 2x squared. Am I getting off the board here? Not quite. Plus 4 times 2x squared. All right? And that's all divided by 2x, and that's cubed. Okay. Yeah, there's a lot going on here. So Different students might approach this differently, but what I'm going to do is I'm going to go ahead and multiply this, and I'm going to get 4x squared plus, multiply this, 8x squared, and then over here, I'm going to get 2 cubed is 8x cubed. Now, how does this fit into anything we've been doing? Factor, factor, factor. What can I take out of that? I can take a 4x squared out of that. I'd be left with 1 plus 2 all over, watch this, 8x cubed. Now, I'm going to simplify this by factor, factor, factor. 4 goes into 4 once, 4 goes into 8 twice. There's 2 x's up here. I'm going to take 2 of them out. I'm going to take 2 of them out of here, leaving me with 1. I'm going to clean this thing up, and I'm going to get 3. 2 plus 1 is 3, all over 2x. Am I off the board? No. So I'm going to keep that right there. Remember, that is the cube. All right, I'm showing my humanity again. Made a small mistake. So this answer down here is incorrect. And where'd the mistake happen? So I erased my work, so I'm not 100%, but I don't think I multiplied these right somehow. So what we end up with, if we square this, is 4x squared, 4x squared. That's why these are 4x squareds. And then if I multiply that out, I think I did that right, 8x cubed. So remember that. If I multiply that together, I get 8x squared plus 16x squared. I'm just going to keep going, which is 24x squared all over 8x cubed. So it ends up being a lot easier this way. And then I cancel. 8 goes into 24 3 times. Take 2 x's out here. Take 2 x's out here. I'm left with 1. So that would be my answer instead of this. Slight mistake. But there is the efficiency rating of the cube. Now we're going to do it to the cylinder. Hopefully I don't screw this up. Let me pause this. Okay. So I take this. This is the surface area formula for the cylinder. Here's the volume formula for the cylinder. Put the surface area in the top, the volume in the bottom. Now notice I've done some simplifying. So I went 2 times 2 is 4. Pi just kind of comes along to the right. X times x is x squared. And I also multiplied this. See, the x times x squared is x cubed. Then the 2 pi just kind of go in the front. So I wrote it like that. Factor, 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 factor. There's a lot I can factor out. A 2 goes into 2 and 4. I see a common pi and x squared. So I'm going to take all that out. 2 pi x squared. I'm left with 1 plus 2 all over. Nothing I can do here, but it's 2 pi x cubed. So I can't factor that because that's one term. Now I cancel. Boing, 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 boing. Pi's go bye-bye. Remember, pi is 3.14. It's just a number. And then I got 2 x's in the top, 3 in the bottom, so I'm left with 1. Notice this turns into that. So as far as efficiency of that product, that packaging design, they're equal.